Now we want to combine these two rational polynomial expressions, but we're subtracting. So again, always watch that sign. Now, this note's just like adding, but watch the negatives, and we still need that common denominator. So I have a denominator down here, and they almost look the same. But remember, common denominators don't come from just adding in a term. Like I can't just put minus 25 and an x squared there. It has to be more of a multiplication relationship. If you ever have rational polynomials, again, factoring is one of your best bets. So this first one, I can take an x out of both those terms. So it'd be x times x minus 5, my 5 on top, minus x over this. They both have a 5 in common. So I'll put 5 times x minus 5. By factoring those, it does appear that our denominators actually have a term in common. So I would say this x minus 5 and this x minus 5 they have in common. Now, this one has a 5, that one has an x by multiplication, so each fraction is going to need that component multiplied into it. So my common denominator will be x times x minus 5 times 5. I'll write that for both of these. Keep it organized. My first fraction had the 5 up top, and it had the x and the x minus 5. It just did not have the extra 5 down there, like that one did. Leave my minus sign. Again, that's super important. The negative makes it a little bit trickier, just like when you're adding and subtracting regular polynomials, it makes it a little bit trickier. So I have the x here times, I had the 5 and the x minus 5. I have these two, so I just need the x. Now I have a common denominator, and so, the line a little crazy there. So my common denominator is still x times x minus 5. You never need to multiply out this denominator once you put common. It's good for me to see that that's how you got the common denominator. 25 is this first one. Bring your minus sign, and then x times x is x squared. Now, in the last slide, I talked about how if you get done, you might want to check if it factors. So if I were to look at this one, it might not seem like it factors. We're always used to factoring being 3 terms. What if I took 5 minus x times 5 plus x? That would actually multiply back out to 5 times 5 is 25. The 5x and the negative 5x would cancel, and I'd have negative x squared. So this term right here does factor. By writing that factored form down here over this equation, I can double check if something simplifies. Now it's very close to simplifying. So I could look right here. These are very, very close. This is a little bit of a tricky step. When they almost match, if we took a negative 1 out of here, if you took divided by a negative 1, 5 divided by negative 1 is negative 5. And negative x divided by negative 1 is positive x. I'm going to leave the second one alone and rewrite my denominator. So look right here. There's a negative 5 and a plus x. Even though they're written in the backwards order, they still cancel. So my answer would be negative parenthesis 5 plus x all over x times 5, or 5x.